In this tutorial, we are going to talk about static equilibrium. So, what is the basic idea behind static equilibrium? So, when we say something is at equilibrium, meaning the net force is zero, okay? That would mean to say the summation of all the forces in x direction, when you add them, they should give you zero. The summation of all the forces in y direction is zero. So, that's the net force is zero. Then also the summation of all the torque should also give you what? Zero. So then when you achieve this, then we conclude that the object is at equilibrium. It is not moving. Okay? The object is at equilibrium, it is not moving. So now I'm going to show you a simple way on how to work around these questions. So let's try to solve this question, which is saying the system in the figure is at equilibrium when m1 is equal to 10 kgs. Find the value of T1, T2 and M2. Assume the pulley to be massless and frictionless so that it does not change the tension in the cord. Okay, and to make things simple, they have given us the answers already. They just want us to find the answers. Okay, so now this type of pulley, what I want you guys to understand is that this T1, it is connected to the same rope as that one. So now, meaning that the weight which I'm going to have here down for M1, I know that for M1 is going to be M1G, that is the weight force. So that tension is the same as T1 there. So I can say that the summation of forces in y direction just for M1 only, okay, is going to be equal to, I have got T1 pointing upward minus M1G pointing downward. So this is going to be zero because we're talking about static equilibrium, something that is at equilibrium. Okay, so this is going to be T1 minus M1G. So if I shift M1G to the other side, it will be M1G being equal to T1. So what is M1? M1 we have been told that is 10. So I'll put 10 here times 9.8 as G being equal to T1. So T1 will be equal to 98 newtons. So the question is find the values of T1, T2 and M1. So now we have T1 and for sure here it is also 1980 newtons. Now for me to find these remaining ones, I have now to start working around the forces in X at the same time the forces in Y. Okay, so one thing we should take note is that T1, if we check at T1, it is like this. So we have 45 here, so that is T1. I can resolve this into components, so it will be T1x and T1y. Okay, that is going to be the same with this other one. So I'll have T2x and T1 or T2y. So this one, it will be the same thing. This is going to be T1x, that's T1y. Now, according to SOHCAHTOA, okay, if I use SOHCAHTOA, sine theta is opposite. Now, in that case, we can clearly see that the opposite, I'll start with T1. So, opposite is T1y, hypotenuse is just T1. So, to make T1 y as a subunit of format, it will be T1 sine theta. So, in y we use sine, in x we use cos. Okay, based on SOHCAHTOA. Then what I have to do now is I need to know that I have got the weight force for this guy which is times g. So I'll say the summation of all the forces in x direction. What forces do we have? We have got this force pointing to positive x-axis, that is t1x. I have got t2x pointing toward the negative x-axis, that is t2x. The summation should be replaced by 0 because it is at equilibrium. So t1x is t1 cos theta minus also t2 cos theta. So you can shift t1 to the other side or t2 to the other side. It's basically the same thing. So you have t1 cos theta being equal to t2 cos theta. So now we have t1 and we definitely know t1, right? Let's plug in t1 is 98 because the angle for t1 is 45 being equal to t2. Then the cos for t2 the theta is 53. So to find t2 I'll divide both sides by cos 53 degrees, even here cos 53 degrees. So therefore t2 will be equal to, so if we get our calculator, we have 98 cos 45. The answer I find divided by cos 53. So the answer I'm getting is 115.14. If you want, you can say 5 newtons. But now I want us to understand one thing. Okay, we'll leave it that way. So we'll say t1 or is t2 is 115.14 newtons, and here is just 115.5. So if there is no difference actually. Okay, yeah. So I believe here I don't know what they did for them to find this answer 0.5, but it's supposed to be 0.14. Okay, from here now I have again to do now another question. If the question was just asking us to find t1 and t2, I would have ended there to say that is the answer. But the question is going further and ask us again. The question is again asking us to find m2. So to find m2, I'm going to use the forces now in y direction. So I'll say the summation of forces in y direction, we have got t1y pointing upward plus t2y also pointing upward minus this m2g pointing downward. So we replace this by 0 because the net force is 0. So this is going to be t1 sine theta plus t2 sine theta being equal to, or minus m2g. So if we want, we can shift this to the other side. So we have m2g being equal to, what is t1? I can plug in the values, or before I even plug in the values, I can write the formula plus t2 sine theta, like that. So the m we don't know, but we know the g 9.8. What is t1? Okay, t1 is 98 sine the angle is 45 plus t2 is 115.14 sine 53. So let us see. I'll divide here by 9.8, even here by 9.8. So these two will cancel out, and then I'll remain with my m2 being equal. So I'm going to do direct for me to avoid the decimal places. So 98 sine 45 plus 115.14 sine 53. So the answer I'm getting 161.2513572. I divide it by 9.8. Okay, so the answer I'm getting, it is 16.45. If I round it off, my M2 will be equal to 16.5 kgs, and for sure here we have 16.5. So that's why I'm saying here they made a mistake. This was supposed to be 115.14 or 115.1, just like that. So let us also see how we can crack this question, which is also under static equilibrium. So the question is saying for the equilibrium situation shown in the figure below, find W2, W3 and W2. Assume that W1 is 800 newtons and that the pulleys are frictionless so that they do not change the tension in the cord. Okay, so one thing we should understand is that so this is W1. So we have been told that W1, it is 800 newtons. So this is also T1. That's what we should know. So this was T2 and this is again T2. So if I find T2, that would mean to say I have also found W3, because what I mean here is for just this part here, one thing we want to understand is that the summation of forces in y direction, since it's not moving, I have got T1 pointing upward minus the W1. Replace this with 0. T1 minus the W1 is 800. Shift 800 to the other side, therefore T1 is 800 newtons. And here the question, they have not even asked us to find W or to find T1. We're just interested in W1, W3 and 2. Okay. Now another thing we have to take note here is simple and straightforward. Okay, so we have been given that this angle here, this angle is 50, this one is 40. Okay, so I'm going to make things simple, I'm going to use these angles here. So I know that from there to there it is 90. So if I do 90 minus 50 is 14, so that is going to give me 14. Then here 90 minus 40 here is going to be 50. Okay, now these are the angles I'm going to use, because I need to get the angle from positive x-axis. Okay, so I'll start now. I know that this one I'll have t2x, then this side here I have got t2y. Same applies to this part. I've got t1x, this side here I'll have t1y. But one thing we should know is that T1, let's first do this. The summation of all the forces in x direction. What forces do we have in x direction? In x direction we've got T1x and T2x, but T1x is pointing toward negative x-axis. T2x is pointing toward the positive x-axis. So I'll say T2x minus T1x. Replace this with 0. So this will be T2x or T2 cos theta minus T1 cos theta. Now we have to shift T1 to the other side, so it will be T1 cos theta being equal to T2 cos theta. But we know what T1 is, and remember I said that for us to find T2, we'll say the summation of forces in y direction. We have got T2 pointing upward here. Okay, let me get this part alone. I show you the forces I'm talking about. So we have T2 and we have W3 there. So T2 is pointing upward minus W2. So it will be 0 being equal to T2 minus W2. So T2 will be equal to W2. So if I find T2, that was going to be my W2. Okay, so let's see. I know T1 is 800 cos, what is the angle? 50 degrees, being equal to what is T2? T2 I don't know, but I know the theta, which is 40. Okay, I divide this by cos 40, even here by cos 40. So these will cancel out. My T2 will be equal to 800 cos 50 divided by cos 40. So the answer I'm getting is okay, 671 671.3 newtons. So these guys, they made a mistake. This answer is not correct. So my T2 now, let me just put it here. Now that I have my T2 being equal to 671.3 newtons, that's my T2. Now we need also to find W2, that is in y direction, meaning I have now to start playing around with the forces in y direction. Okay, so then we are going to say the summation of forces in y direction, we have T1y pointing upward plus T2y pointing upward minus the same W2, which is the weight force. Replace this with 0. T1 is T1 sine theta plus T2 sine theta minus, this is going to be M, or it's just W2 because we want to find W2. Shift W2 to the other side. So what is T1? T1 we have already found. It is we were given, actually it is 800. Sine the angle for 800, it is 50, plus T2 we have found 671.3 sine 40. Okay, so what will be our W2? So we have 800 sine 50 plus 671.3 sine 40, and the answer I'm getting is 1044 0.3 newtons. That is the answer they found here. So that now you should know that this is wrong, because if you plug in this one, you will not get that one. Okay, so now sometimes you might be asking yourself question. We have found W1 or W2 and W3, that is it. Sometimes you might be asking yourself this question to say, why did I choose to use these angles and not the angle which I was given? It's basically the same thing. I'll end up having the same answers. Now let's see if I'm to use the same angles which have been given. If we see, well, okay, let's see if we're going to get the same answers. So one thing we should take note is that then this is going to change now. So we have got that one. So this now is T1x, okay, because that is T1, meaning this is T1y. At the same time, if I also extend this to this side, this is going to be this is T2, sorry. Then this is T1x, and I have got T1y. In that case, I'm going to change now. Okay, and we already know that this is T1, and we have been given this is 800 newtons. So we know that T1 is equal to W1. So T1 is also 800 newtons, like that. At the same time, we should also take note that this is T2 and then we have W3. So if I find T2, it's the same as I'm finding W3. Simple, right? So it will be the same actually. The summation of forces in x direction, I've got T2x minus T1x. But one thing we have to take note, this will be replaced by 0. So this is T2 cos theta minus T1 cos theta. Shift T1 cos theta to the other side. Now here, just a minute before we even go there. I can't use cos. It's going to change. You look at the triangle which we have been given. So the triangle which we have, guys, is this. The angle is here, 50, and this is Tx, and this is Ty. T1, okay, let's start with T2. This is T2y, and this is T2. So the opposite of the angle is that one, meaning that in this case now it's going to change. So it will be sine because of the triangle. That's the reason why I had to get this angle for me to use cos in x. But in this case, if I'm going to use the original angles which have been given, it's going to change because you look at the triangle which you have. So in this case, it will be T2 sine theta minus T1 sine theta. So shift T1 sine theta to the other side. Let us see now. So T1 we have been told is 800. Sine theta, it is now the angle for T1, it is 40 here. It is 40. Then T2 we don't know, it's the one we are trying to find. Sine 50 divided by sine 50, even here sine 50. So these will cancel out. Therefore my T2 will be equal to, so you do 800 sine 40 divided by sine 50. Okay, so you still end up having 671.1, okay, newtons, like that. Okay, so you can clearly see that I also got the same answer. Now for me to find the other one, the W2, so now T1 is the same as it, so meaning that W3 is now 671.1 newtons. It's basically the same thing. So the summation of forces in y direction, it will be T1y plus T2y minus W3. This will be replaced by 0. Now this is going to be adjacent over hypotenuse, which is cos, if I use those angles. Shift W2 to the other side. You end up having, what is my T1? My T1 is 800. So we have, cos the angle for T1 is 40 plus T2 is 671.1 cos what? Cos 50 for T1. Okay, so if I plug in the values, my T2 we found 1044. So let's say 800 cos 40 plus 671.1 cos 50. So I end up having the same answer. So as you can see, now you choose which one is good for you. Okay, but the first method I had to get that because I know most of the times you get confused when we use sine in y, we use cos in y, then we use sine in x. You get confused. So that is how you work around with such problems. Okay, here is a question which I have for you. The question is saying the figure below shows a weight suspended by two ropes. The tension in rope 1 is 30 newtons. Draw a free body diagram showing the resolution of forces and find the weight W of the object. So the forces that we have here, we have been given this one already, so there is no, the only force that we have to resolve is the tension 2. So I'll call this one as T1 and this one as T2, of which I know that to resolve this is going to have the x component and the y component, of which the x component is going to be T2x, the y component will be T2y. Using SOHCAHTOA, I can see that this is Z, is forming Z. The angle which is here is the same as the angle which is there, so meaning that here we have 40. Another way on how you can find that is just by doing this. You know that this is going to give you 90, so you have been given 50 here. 90 minus 50 is 40. That's another way of finding that the angle here is 40 degrees. So using SOHCAHTOA, T2y is T sine theta, T2x is T cos theta. Now let us first, we are trying to find W, and W is in y. So the summation of all the forces in y direction, we have got T2y pointing upward minus W which is pointing downward. This one will be pointing downward. So we have got the mg there. Okay, so that is the weight. Now when you're talking about static equilibrium, meaning an object is not moving, therefore you replace this with 0. So this will be T2 sine theta minus that. Shift W to the other side, we have this. The angle is 40. Now I want to find W, but I don't have T2, so I will leave it here and say that is equation 1. Then I need to go for the forces in x direction. So in x direction, we have got the T1 pointing that side. Okay, it is just there. Okay, it is not at an angle, so you can say T1 is going to be T cos theta. The theta there, it is 0, so 30 cos 0 is still T1, which is 30. So that's why I'm going to put just T1 minus T2 x. Replace this with 0. T1 minus T2 cosine of theta. Shift this to the other side. T2 cosine of the theta is 40, should be equal to T1. So divide both sides by cos 40, even here cos 40. I'm trying to find T2. So we have T2 being equal to T1 is 30 divided by cos 40. So we're going to have T2 being equal to 30 divided by cos 40, 39.16. So 39.16 is my T2. Okay, 39.16 newtons. After finding T2, I can now go ahead and find W, which is going to be T2 is 39.16 sine 40. So the weight force they want us to find, it is 39.16 sine of 40, which is 25.17 newtons. So that is the answer for this question. The weight force is 25.17 newton, and then the forces for us to write a free body diagram is if you want, you can write the free body diagram in this manner. Let me show you. You have this, you just draw it like this. Okay, then you have that. The forces acting at that point, you are going to say, or even here you can just do it like that. So the force, you have got that force. So that force we expect, so you say that is T2 and this is T1 and that is, so you put arrow, that is mg, that is the weight force. So it is going in this direction. I have that. So that is 40. So this is T2x, that is T2y. You can resolve the free body. So you report your free body diagram in this manner. As simple as that. There is nothing complicated here. Okay. A thin rod, 1 meter long, has masses of 1 kg and 1.5 kg hanging at its end. Find the point at which the rod can be lifted without the rod tending to rotate. Assume the weight of the rod to be negligible. See the figure below. So the total distance from this point here to that point is 1. So if this is x, okay, meaning that the remaining part will be 1 minus x, of which x we don't know. I hope you get the logic there. This, if everything here is 1, and then x, we have x here, so to find the remaining one is 1 minus x. Okay, so this is w1, okay, and that's w2. Now I will keep on mentioning this whenever I make a video under static equilibrium. Static equilibrium, there are only two conditions which you have to know. The net force is 0 and the summation of all the torque is also 0. But the net force we are talking about, the summation of all the forces in x direction is equal to 0 and the summation of forces in y direction is equal to 0. So if you have been given a question which involves angles only and there is no distance, then you are going to use that question to just find the missing variables using the first condition. The net force is equal to 0. So you will just be using the summation of forces in x and y. That's all. If you have been given the question that involves the distance and there are no angles, you are going to use the summation of torque. If the question involves both the angles and the distance, then you are going to use the combination of these two. So like this question which I have here, I only have distance. So then I'm going to focus on torque. Okay? So we do know that torque is basically force times the perpendicular distance. Okay? For example, if this is the force here, the perpendicular distance will be this one. Okay? So this is my pivot. So our goal is to find the value of x in this case. That is the distance they want us to find. Okay? Now, one thing we should know is that 1.5 kg block will be pushing this system to move in that direction. Let's call that torque 1, but this other one will also be pushing it to move in that direction to make it balance. I'll call that torque 2. So one thing we should know is that clockwise, or you say the summation of torque should be equal to 0 if you want, the summation of torque should be equal to 0. What torque do we have? We have got this torque, so you can assign anything. You can say this should be positive, this should be negative, but you end up having the same answer even if you swap them. So if T1 will be positive minus T2 being equal to 0, shift torque 2 to the other side, you have this. So torque, okay, torque is force times distance. So I'll say, what is the force? It's the weight force. So I'll say W1 times the distance should be equal to W2 times distance. But what distance are we talking about here? And what W1 are we talking about? The W1 is M1G. The distance we are talking about, the perpendicular distance from the pivot all the way to where W1 is X. That is the perpendicular distance. So we have X should be equal to, this will be M2 times G, then the distance is 1 minus X. 1 minus X, like that. So now we do not have mass, or we have masses, okay, but we can cancel G. We have G both sides. So you can say that M1 times X will be equal to M2 then 1 minus X, like that. We plug in the values. What is M1? So M1 is 1.5, okay, times X being equal to M2. What is M2? M2 is 1.0, open brackets, 1 minus X. So it will be 1.5 X being equal to, if I multiply this, will be 1.0 X, 1.01, then we'll have minus X. Shift this to the other side, it will be 1.5 X plus X being equal to 1.0. If we add these two, we'll get 2.5 X being equal to 1.0. So you can divide both sides by 2.5, 2.5. Therefore X will be 1 divided by 2.5, that is 0.4. So it has to be placed 0.4 from the pivot, okay. So the answer here is 0.4. Now one thing we have to understand is that this 0.4 is just here, okay. So for you to find this distance, it is now 1.1 minus X, which is going to be 0.6, okay. There is no there is nothing difficult about this question, and I think I've solved different questions under this topic. So I would request you guys to go back and also watch my videos on website under the same topic. Then the last question is saying, state the condition of translational. So translational is something that is moving, is either in x direction or in just y direction. So the condition is that the summation of the forces, okay, the condition is that the sum of the external forces should be equal to 0. That's the condition of translation. So you have got the summation of forces in x should be equal to 0, summation of forces in y should be equal to 0. So you just say the summation of all the forces, or the summation of the external forces, should be equal to 0. That's all, okay. A uniform bar of length L and weight W, which is W1, to be equal to 35 Newton, is suspended at its end as shown below. A block of W2, which is equal to 10 Newton, is placed at 1/4 distance from the right hand side end. What are the magnitude of the force N1 and N2 exerted on the bar? Static equilibrium, when we're talking about this topic, we need to understand one thing. When we're talking about static equilibrium, we're talking about an object which is balanced. There are three principles which you need to be familiar with under static equilibrium. The summation of all the forces in x direction is 0. The summation of all the forces in y direction is also 0. The summation of torque is also 0. Now the challenge comes in to know where you are supposed to use this. Torque is the force times distance. Okay. Now, what we need to understand here is that there are some questions which will require us to use all the three conditions for us to to solve the question. Some they are just we are required to use only the first and the second one. Then other questions you are only required to use the third one only. But how can you know that this question I'm supposed to use the first conditions alone? In a case where you have been given angles only and you have got no distance, since we know that torque is equal to force times distance, there is no distance, you have only been given the angles, and they are trying to ask you to find maybe the forces. You can only use these two. You only use these. So you only use these if you have been given a problem only involving angles. There is no distance. If you have been given a question which only it doesn't have angles but it only has the distance, you use only torque. Only torque can give you the condition. Only torque can give you the answers you are looking for. So this is when you have been given distance only. There are some problems where you're going to be given both distance and the angle. You use all the three conditions. You use this and that. Now, from the question which we have here, we can clearly see that we don't have any angle. We are only dealing with a distance. Therefore, only torque is enough for me to get what I want. Okay? So what I'm going to do now is I'm going to say I'll use torque only. So we know that I'm going to get one of these as my pivot. So let me start with this. I'm going to get where there's n1 as my pivot. When I get n1 as my pivot, what should we know? What we should know is that the torque at that point is going to be 0 for n1, meaning I'm not going to consider n1 for that. Okay? Now, we know that the forces which are going downward here, W1, which is 35, W2, which is 10. If I add these two forces, 35 plus 10 is going to give me 45 newtons. Meaning that the force N1, when I add N1 plus N2, because we're talking about static equilibrium, this object should not move. When I add these two, I'm supposed to get as well 45 newtons. What does it mean? When I just find one N, I can also find the other N because I know that the total is 45. So if I get this one as my pivot here, meaning I'm remaining with this N2 here, which is going to be pushing this beam in this direction. Okay? Then let's call this, since it's N1, I'll call it torque 2. This is going to be pushing this in this direction. At the same time, this will also be pushing it in that direction to make it balance. So I'll call this torque 1. I'll call this, okay, let me call this torque 2. Then let me call that torque 3. So we have clockwise. When you are going in this direction, is clockwise. When you are going in this direction, is anti-clockwise. So the rule of this is clockwise should be equal to anti-clockwise. I'll say clockwise should be equal to anti-clockwise. Now, clockwise, how many forces do we have? We have got how many torque do we have? We've got torque 1. They are moving the same direction. Torque 2 should be equal to, and clockwise I only have torque 3. Torque, in this case, torque is the force which is going to be, the force is W1 times the distance. Okay? Then this one is going to be plus this, let me call it distance 1 as well. This one is going to be W2 times distance 2 is equal to, my force here is N2 times the distance, which I don't know. I'll just call it 3. So what we should know now is that the distance from this point here all the way to that point, we have been told that is L. I'll put L. Meaning for D3 here, I'm going to replace D3 with L. The distance from this point here to half, this is half here, is 1 over 2L. Then again, there's another distance from this point all the way to that point here. I can clearly see that it is in between W2 and the N2, which is going to be, we have been told that W2 of 10 Newton is placed 1/4. 1/4 is 1 over 4. So 1/4 meaning from this point to that point is 1/4. Meaning again from that point to that point is 1/4. So I can say half plus 1/4. Okay? Which is going to be, here I'm going to have 4. 2 there is going to be 2. Here 1, 3 over 4. Okay? So here I'm going to have W1, I have it already. It's going to be what? So here I'll have 3 over 4L. W1 is 35. D1 now, in this case, D1 from this point is going to be half L times half L, like that. Plus. Then I have this one now. This is going to be is 10 times, I have 3 divided by 4, then L, like that. Okay? This should be equal to N2. D3 is the distance from Toku, from this point here all the way to that point, which is L. At this point, I can clearly see that L appears everywhere. I can cancel L. So I'll have 35 divided by 2. I'll have 17.5 plus 10 times 13 or times 3 divided by 4. I'll have 7 point what? I'll have 7.5, like that. I'll have 7.5 is equal to N2. So if I add those two, 7.5 plus 17.5, I'm getting 25 as my N2. Now, we said that the total should be 45, meaning that N1 plus N2 is equal to 45. So, N1 I don't know. N2 is 25 is equal to 45. If I shift 25 to the other side to be 45 minus 25. So N2 or N1, sorry, N1 will be equal to 45 minus 25, which is 20. You can either use what I have used here, or you can also come back and plug in the values here. You use the same talk to come up with the values. So my N1, my N2, sorry, is 25 degrees. Oh, 25 newtons. Again, if I get this one as my pivot, meaning N2 is not going to be considered. Now I want to find N1. You can either use that method which I've just used there, or I'm going to use another method. If you want, you can follow the one I'm going to use right now. So if this is my pivot, this is going to be pushing this guy in that direction. Then these two are going to be pushing it in this direction now. So now I have also clockwise is equal to anti-clockwise. So clockwise, I have what? I have, I'm going to call this torque 1, torque 2, torque 3. I have torque 3 should be equal to anti-clockwise. I have torque 1 plus torque 2. So torque is force times distance. In this case, torque 3 is N1. Okay, the distance, let me just put D. Okay, I'll put D. Now that distance is L in short. It's the distance from this point all the way to that point, which is L. Should be equal to T1 is W1 times the distance now for this is still half to that point, 1 over 2L plus. For T2 now is from this point to that point, which is 1 over 4. So it will be W2 times 1 over 4 then times L. So let's plug in the value. N1 we don't know, times L. W1 is 35. 35 times 1 over 2 then this, plus W2 is 10. 10 times 1 over 4L. I can cancel L. So I have N1 to be equal to 35 divided by 2, which is 17.5, plus 10 divided by 4, 2.5. So N1 will be equal to 17.5 plus 2.5 is 20 newtons. As you can see, using that one and this one, I'm able to get the same answer. So that is it for this question.